Okay, let me see here. This is section 3.5. It's pretty short and it's really just about these types of functions called rational functions. Those are basically, I think we've talked about them before, just fraction type algebraic fractions. So a rational function will look like this. So whenever you see a asymptote, which is a boundary, a vertical asymptote, if the graph can't cross it, then it's an asymptote. And that always happens when you have division by zero at an x. So when you see that line, which is happening at 1, the equation of that line is going to be x equal to 1. So this is the equation of the vertical asymptote. And then the horizontal, which is a 4, would be y equal to 4. Okay, so that's how just by looking at the number, horizontal is y, vertical is x every time. So right now, they want us to just look at the explanations, have some more answers and details. So intercepts are pretty easy. You just see where does it touch the x-axis? Right here at -1. And that's it. So we just have this one. Y-intercept is right there and never nowhere else. Nothing crazy. But now vertical, like I said, this would be x equals uh, 1, the ugly x. There you go. Y equal 4. There we go. See, -1 is the intercept. Y is -4. It's just right here. Nothing crazy. They're giving us the graph, so we're just getting information. Now, vertical has to always be x equal to the number where it's hitting the x-axis. So it's going through 1, so therefore x equal to 1. Y equal to b is horizontal at 4. So once you have all that info, we can write the domain. So this is a little harder, but you've done domain before. So basically all we got to do, remember domain has to do with the x, is include everything except that vertical asymptote. So notice if you look at the graph, it goes all the way to the left forever, all the way to the right forever. It only skips this location, right? So that number, the way you would write it is like, well, from negative infinity, right? All the way until 1 is this section, all the way up until here, going to the left forever. And then after 4, or sorry, after 1, we keep going, right? So everything after 4, forever. So that's where this comes from. We're basically just kind of working around the hole or the vertical asymptotes. Remember, we said we can't cross it. And then range, right, is up and down. So all you got to do is everything above that number and below that number. So that number is 4, right? So everything above 4 or below 4. So from negative infinity up until 4, no brackets because we're skipping over it. Union everything after 4. So you just look at the picture. Range is y values, so up and down. Domain is left and right. So remember where the asymptotes are and see if the graph jumped over it or crossed it. Vertical, you never really cross, but the horizontal, sometimes you do. And I just sent out a PDF for the rules of all the asymptotes. But anyway, that's how you solve these guys here. Just looking at the graph. Let's do another one. Here's another one. Pretty short. So graph all vertical and horizontal asymptotes. So let me show you the rules that I sent you just now. I can find the PDF. There it is. So vertical asymptote. That's always going to happen when the denominator is equal to 0. So you just take the denominator, in this case it's x plus 4, set it equal to 0, solve for x, and you're going to get All right. You can also just see it by plugging in -4. But if you're rusty, just solve for it. There it is. So this is the equation for the vertical asymptote in this current question. So whenever you start and the answer vertical, set the denominator equal to 0. Horizontal is the annoying one. You have different cases. So if the degree is higher on the bottom, then you're going to use number one. If they are equal, then you take the coefficients of the leading coefficients. You just divide them. So if it's both squared on top and bottom, so you take the numbers in front. Now, if the power on top is bigger, the degree, then you have no horizontal. You might have a slant though. So let's go back to the question. So remember, degree, we have case one on this one. Just don't forget that. And they have it in the notes, and I sent these notes to you too. But check it out. They're right here. If n is less than m, so the degree of the top is 0 because there's no variable. Degree of the bottom is 1 because the highest power down here is 1, right? So 1 is bigger than 0, so we have case 1. That's going to be a vertical asymptote. And then, as we said earlier, set the bottom equal to 0, and you're going to solve for this by setting this to 0. So that's what I did a minute ago. So to find both asymptotes, all you got to do is say x equals -4 for the vertical and y equals 0 for the horizontal. That's how we did. Just graph and label the asymptotes. That's it. Nothing crazy. So this homework's pretty short, so let's keep going. Okay, so this is the next one, number 3 in the homework. So check it out how the degree of the top is 1, and it's the same as the bottom. So these are equal. So that's going to be case 2. Remember we said you just take the coefficients and divide them. So you would take the leading coefficient, meaning the number in front of the highest power for the top and bottom, and divide them. So the horizontal is going to be this. -8 divided by 2 is -4, +4, right? And then you set this to 0 to get the vertical. So what is the vertical? Okay. Subtract the 9 over, divide by -2. And we get positive 9 over 2. So there's the vertical. So we just got to graph them. So you would say, okay, well, those are my answers. Vertical asymptote x equals 9 over 2, right? We said there's a dashed line. Horizontal is case 2. So that would be the two numbers divided, -8 divided by -2, which is a 4. Right there. Let's look at the example for a little more details. Hmm. So there it is. They set this to 0, and that's how they got this number. We just did that. And then we saw the degrees are equal, right? N and M. N is the degree of the top, M is the degree of the bottom. Since they are the same, we have case 2. See, right here. Numerator and denominator both have degree 1. Therefore, divide this. Thus, horizontal asymptote is there. And then you just plot them. Plot them on the graph. Nothing crazy. But just remember you got to follow these rules, which I sent them to you, but they're also in the examples. So, or you can write them down. I think it'd be, I don't want you to memorize it. I'd say write them down. Okay. Okay, let's do this one and then we'll call it. I'm not going to do the factoring because you should know how to factor at this point. So notice degrees are the same. So we're going to do the division thing. This is case two. But whenever you have quadratics, you got to factor first. So once you factor everything, you're going to get here. Factor the top, factor the bottom. All right, and then you got to set this to zero, where you would set this to zero and end up solving, right? You have x plus 2 once you get there. X plus 1. Oh, dang it. Solve for zero for x on each one, you're going to get x plus 2, just like we've done before. Oh, man, it's getting tired. Subtract the 2 and subtract the 1 over. It's a 1. You'll get this. Anyway, so those are your two vertical asymptotes, which is what they did to get this. So you just graph them. Now, to get the horizontal, remember we said if they're the same, you divide the coefficient. So this has a 1, this has a 3. So y equals 3 over 1 would be your answer. And that's what they're doing here. So since they are both the same degree of 2, take the number 3 divided by 1. This 1 and this 3. So horizontal is y equals 3. Vertical is x equals -2 and x equals -1. So just graph both. And that's it. All right, but anyway, so basically understand asymptotes, understand how to find the vertical, horizontal, be able to factor and reduce. And that's pretty much the main thing. All right, that's it for this section.